Okay, here we go. Watch out, here we go. Okay, welcome to Physics 1600. This is lecture 19, and today we have a symphonic extravaganza where there will be actual music coming from your speakers or from sort of a music video of the universe. And so let's get started here first by guessing what is this. You probably know sort of what it is. But if you don't, it's pretty cool. It's big and it's nearby. Okay, so here's the obligatory slide. This is still Introductory Astronomy, Physics 1600 for people keeping score. Lecture 18, we're going to talk about all different types of galaxies today. And next lecture, we're going to go into the universe and talk about what's the rest of the universe like. Oops, and this time we have a aggressive, it's on a timer today. So anyway, I'm this person, this is the place, this is the web page, and you don't need to be here. Let's see. I'll just wait for it to update automatically. Go, go. It's supposed to be every 15.23 seconds for people keeping time at home. And I'm getting bored and it's not doing it. All right, here we go. So you're responsible for the lecture material, the Wikipedia stuff, the astronomy pictures of the day, quizzes 1 through 9, all of which are worth 10 points. And I'm told that one was mistakenly worth 19 points, and that will be changed. So homework 10, also worth 10 points, will be released later today, and you can find all the action at courses.mtu.edu. And I get feedback from my studio audience here. Okay, so today we're going to be talking about galaxies, but Wikipedia recognizes first and foremost the word galaxy. Although you can put in galaxies, it'll just redirect you. Quasar, that's a good one you should look up today. We should do that a little bit more later. Galaxy groups and clusters is also a big one. So we want to make sure to do that one. Okay. So today we're going to be doing this is what I want you to do. I want you to, actually I'm going to freeze it here. Take out a pencil and paper, everybody, and at home. We'll wait. Please whistle Jeopardy music to yourself. We're going to be going through a lot of galaxies set to music, and your job is to write down what type of galaxy you think it is. So let's review the types of galaxies that there are. Here we have something from the web. So there's sort of, well, hard to explain. These are elliptical galaxies here. This is called a lenticular galaxy, S0. And these are spiral galaxies here. So those are 3 general groups. Spirals, though, are broken up into 2 different kinds of spirals. There are the barred spirals with a B in them, and there's the unbarred spirals, spirals that just don't have a bar across the center. And they don't have a big B as their second letter. So S will stand for spiral. B will stand for bar. S0 is a disk galaxy. A lenticular is a disk galaxy, and it's called 0. I forget why. Must be historic reasons there. So over on this side, we have E for elliptical galaxy. And here are pictures. An E0 galaxy, the 0 tells you more or less about its ellipticity. So an E0 appears to be circular, a circular disk on the sky as pictured there. The other extreme of that is an E7 galaxy, is an elongated, very elongated elliptical galaxy. And so far, I don't know if we found any ellipsoidal type galaxy that is more elongated than E7, and there's a way to calculate what E7 is. So you don't have to get the number exactly. You can guess at the number. You're not going to be great at it anyway. I mean, this is sort of fun. So you're just going to keep these, and just keep these for yourself to keep you awake and watching carefully. There are several ways of classifying galaxies, but this one was come up with by Edwin Hubble. He's the same guy who essentially discovered the rest of the universe and helped resolve the Curtis-Shapley debate of 1920 by observations of Cepheid variable stars in the Andromeda galaxy, showing it was an external galaxy. So now I'm going to spill the beans and say that, yes, there are lots of external galaxies. Hubble was right. And We see them with powerful telescopes across the universe, and one of them, the Andromeda Galaxy, you can actually see without a telescope. Actually, you can see 4 galaxies with the unaided eye. 2 from Houghton. The 2 you can see from Houghton, Michigan, are the Milky Way galaxy, the band of the Milky Way, and the Andromeda Galaxy, M31. You can pick up 2 more from the southern hemisphere, the Large Magellanic Cloud, the LMC, and the Small Magellanic Cloud, the SMC. So let me point out that besides these galaxy types, there are 2 other types that you can use. I for irregular. An irregular galaxy is just completely strange and cannot be classified in any way. A peculiar galaxy, P, so I is for irregular. P stands for peculiar. I might have misspelled that. Yeah, I missed a U in there. So you can have an E0 peculiar galaxy. So you can put E0 peculiar as if you think that's it, or a SB peculiar. So our own home galaxy is thought to be the Milky Way, either an SBB or an SBC, with big spiral arms. The sprawling spirals you see with a small nucleus are SCs. Generally, if they have a big nucleus and they look like these caricatures or these here, that would be an SA galaxy, generally a big nucleus and not so prominent spiral arms. The smallest nucleus and the most sprawling spiral arms are found in the SC galaxies, both SC for spiral of type C and SBC for barred spirals that also are of type C. Same, B is in the middle. The SBBs and the SBs are in the middles between. They have middle-sized nuclei. Okay, so you can also have galaxies that collide, and you can just write colliding galaxies. There's also groups of galaxies, and there's also clusters of galaxies. So beware, because I didn't make it easy. I've mixed in strange stuff along the way. So the way it's going to work is this. I'm going to go through with music and be relatively quiet during the approximately 15-minute show, where you'll see a new galaxy approximately every 15.23 seconds. After that, I'm going to run through all the same slides again, and then I will talk about what I think they are, and you'll see the link to which APOD it is. So if you want to know more, you can follow that APOD link and know more about that galaxy. And that will be pretty much it for the day after we go through them, although today actually I'm going to be reviewing astronomy pictures of the day for the past week also. So please put on your safety belts. And we ready? Okay, so when you see the next one, the music will turn on and you start recording galaxy types. Ready, set, go. They start out somewhat easy, but sometimes it's not so easy. That might be the last one. Let's see if there's another one. No, we're back to that one. All right. I have to quickly turn off the timing manually. Okay, from current slide. Okay. All right. So first of all, did anyone recognize the music? The studio audience. Does anyone know who composed that music? That was Ludwig van Beethoven. It was the fourth movement of Beethoven's first and the fourth movement of Beethoven's seventh, which aren't commonly heard these days, but I think are pretty rousing. So if you're just interested in that, you might want to listen to some Beethoven. Okay, so they were set to Galaxies. So sorry about the little horn in the middle there. I don't know if I can delete that, but this is a spiral galaxy. Can we move this? No. Oh, forget it. Sorry. Never mind. Okay, so ignoring the strange shape in the center, this is a classic spiral galaxy. A very small nucleus. I would say this would be spiral of type C. So it's hidden galaxy IC 342. So it was taken by an amateur astronomer who had some pretty sophisticated equipment and image processing. So the index catalog 342. So it's difficult to see this without a small telescope. Okay. Okay, here's another one, M33. So this is a brighter one. I think this is near M31. Triangulum is a constellation. And here we see some sprawling spiral arms. So what is it about spirals? So this is probably also an SC type. So spirals have arms. Let's see, spirals. They have arms. They have they're blue disks. Well, they have disks. Let's do that first. The disks are blue disks because of all the bright blue stars there. They have red star-forming regions. They appear red to the human eye because it's their emission nebula, like we've seen many times. So red in quotes, star-forming regions. And then there's a dark dust. These are all the characteristics of what makes a spiral galaxy. Okay, so this is probably a C type, M33. Okay, M81, a very massive galaxy. Let's move that cursor down here. So this is more tightly bound. I don't see a bar, so I would say it's SB type. Okay, this is, yeah, Centaurus A. So Centaurus A is the result of a galaxy collision. So I think one of the galaxies is an elliptical galaxy. So here we see an elliptical profile, but there is some kind of disk galaxy that got eaten or is in the process of getting eaten. So it's elliptical galaxy. The most massive one, the one that dominates, is the elliptical galaxy. CFHT is the name of a telescope in Hawaii, Canada, France, Hawaii telescope. And what's good about it is every month they put out a spectacular picture from their big telescope. I don't think it's 8 meter. I think it's a 4 meter telescope. Okay, elliptical galaxy M87, right here. You notice there are other ellipticals in the field. These are full galaxies, all of these. This is just a nearby star in our own Milky Way galaxy. So I would say this is E, oh, I don't know. 0 would be perfectly circular. So I would give it maybe an E2. It's definitely not E7, just guessing. Okay, this is deceiving. It's not this one that's interesting. That's a star. It's a foreground star. These things are due to the things that hold the telescope secondary mirror in place. And so that's just diffraction spikes. That's not real in the universe. That's created by the telescope. It's this guy here that's the most interesting. So this is a dwarf galaxy. So I didn't tell you about those. Dwarf galaxies are frequently dwarf elliptical or spheroidal. The easiest to type is the elliptical. And it's sort of like a big fluffy globular cluster, but it contains many more stars than a globular cluster. So an elliptical galaxy, so let's go back maybe and go back and look at ellipticals again. So ellipticals. They are known by, let's see, relatively, they're not so red. They're reddish stars. They're older than spiral galaxies. They're essentially the center parts. The bulges of spiral galaxies are similar to ellipticals. They have little or no, let's put little, dust or gas. And they have no spiral arms. So that's how you know more about what elliptical galaxies are. Okay, got that? So let's jump to the next one. So this image was taken because there is a supernova there. So a common joke is you know where the supernovae are on the sky because there are arrows pointing to them. No, it was just put in there later. So this looks to me like a SC galaxy. So it's a very small nucleus, big sprawling spiral arms. One common misnomer is that in these regions between the spiral arms, there's very little mass. As I said, I think last lecture, there can be almost as much mass between the spiral arms as the spiral arms. The spiral arms light up because there's bright galaxies there. Bright stars there. No, not bright galaxies. There are bright stars there. Typically young stars. So what's this strange beast? Well, it tells you here. It's the Hubble Space Telescope image of NGC 5866. This is a spiral galaxy. Of what type, we don't know, because we're looking at it from the side, or from the edge on. So here's all the dust. Dust is what stands out, and stars shown there. You can't tell, though. So here's a spiral galaxy that's an obvious bar type. So if we were there and looking down, we'd have a spectacular view of something that might be like our Milky Way galaxy or the Andromeda galaxy. But we can't tell from here. A spectacular spiral, the center of M51, the Whirlpool galaxy. So it's really a tremendous amount of detail that can be gotten for this galaxy. And it looks to me to be, I think it's an SC type galaxy, although if you look at a wider field, it's colliding, I think, with another galaxy. But tremendous amount of detail. Here you see the spiral structure go out, the dark dust lanes go out. Lots of reddish emission nebula here, lots of star clusters you can see when you start seeing the high resolution. I believe this is probably a star in our own foreground galaxy, so there's not a star that bright. Another strange type galaxy, this is a ring galaxy. So inside is a galaxy that probably went through it. Here's the center of that galaxy. There's a ring of star formation instead of spiral structure. This typically happens if one galaxy goes through another galaxy. So galaxies collide all the time. Small galaxies particularly colliding with big galaxies or being eaten by big galaxies. And so when that can happen and the small galaxy is massive enough and goes near enough to the center, you get a ring of a density wave moving out and rings of star formation, as in Hoag's object right here. Another ring galaxy. It's from a Hubble Space Telescope. It wasn't bright enough to get a smaller catalog, so it's in the AM catalog. I think this is the approximately where it is on the sky. So 6 hours, 44 minutes in right ascension, minus 7 degrees, 41 minutes declination. A ring galaxy. Let's put that, write that down, ring galaxy. Okay, here you see a bar, essentially a bar. This is, I would say, an SB, I guess we'll call it SBA galaxy, NGC 1350. I'm going to speed up because we're running low on time. This is the Sombrero galaxy. Tough to type. Don't know if one's officially on record for it. So I'm just going from what I see. I haven't looking up. Again, from Hubble Space Telescope, tremendously expansive and bright center, although an impressive dust ring. So this one is seen nearly from the side, so it's tough to tell. Seems, though, I don't know, I will avoid. It's a spiral of some type. Maybe it's spiral peculiar. Okay, so here's a galaxy that has unusual dust coming off it. These are all galaxies here, but it's this galaxy that has unusual dust. I don't know what kind of galaxy it is off of there. Okay, this shows you that spiral galaxies need not be flat completely. Sometimes, in particular if they're interacting with another galaxy, they can have a warped disk. So here you see the warp of this disk here. It's clearly not flat. This is an irregular galaxy. Just strange things going on, unable to type it, so it's just irregular. Okay, barred spiral, big bar. I would say maybe this is an SBB. Impressive bar across. NGC 1300 taken from the Hubble Space Telescope. Tough. I would call it irregular. It's got different groups of stars forming. It might be two small ellipsoidal, spheroidal galaxies, dwarf galaxies, or a few that collided. Here's a background spiral, but that's not what we're interested in. This one is much further away. This is much closer by. Okay, this is an unusual colliding galaxy that collided. The Sleeping Beauty galaxy appears to be of type SA right off. However, if you look at its center, strangely enough, the center is rotating in the opposite direction from the other part. So there's a collision of two galaxies. I'll guess at the directions. Maybe this one goes this way, this goes that way. So you don't see that, and I don't know of any other galaxy that's known to happen. Another spiral galaxy seen sideways. Not sure of the type, just spiral. Big expansive spiral galaxy, fireworks galaxy. Call it no, not A. Call it SC. Okay, sombrero galaxy. This time seen in infrared light, where this dust typically glows in infrared, and there you can see it. Okay, a dwarf galaxy. This is one of the irregular dwarf galaxies, so it tells you right here, dwarf irregular. I think it's a satellite galaxy of the Milky Way. So it might be eaten eventually. Some of these are hard to find on the sky because they have relatively low surface density. This is the Andromeda galaxy itself. This is where the music changed over to Beethoven's Seventh. So this is one of the most spectacular images of any galaxy, in particular the Andromeda galaxy, the one we can see with the unaided eye from the right time of day, tonight, if it's clear. The Andromeda galaxy and our Milky Way form the local group of galaxies, or dominate the local group of galaxies with lots more smaller galaxies. Andromeda is thought to be slightly bigger and more massive than our Milky Way, but comparable. So our Milky Way looks a little bit like this, but with more of a bar in the center. And this is a small galaxy that will be eaten. Okay, a nearby dwarf irregular galaxy, Leo A, so it's said here what it is. Another galaxy, spiral galaxy, seen sideways. Here you can see the central bulge, it's called. Here's another galaxy here that could be lenticular. Looks like an S0 up there, because you don't see any spiral structure. So early on in my career, I spent some time trying to type faint galaxies on glass plates even, and found, I don't know, it might be one of astronomy's secrets that many S0 galaxies, if they were much closer to us, we would either see the spiral structure or we would call them spirals, or we would see that they're ellipticals. So I think many lenticular S0 galaxies aren't, but that one's dim enough to look like it right now. Okay, this is spiral peculiar. We're not sure why. There's this galactic wind of tremendous amount of dust and gas coming off of M82, but there is. I think this is interacting with M81, but it's not. M81 is far out of the picture. We've seen M81 before. Okay, M83, it's like the Pinwheel Galaxy, but it's happening in the south. You might call this a bar. You might call this SBC. Okay, now we're getting into groups of galaxies. Here's a spiral galaxy that might be SC. This one also looks to be SC. This one is some kind of peculiar spiral galaxy because it seems to be asymmetric. It has a double dust lane up there and no dust lane down there. So that's spiral peculiar. I can close that. Okay, M66, just again typing it off the top of my head, I would say this is an S could be a bar, SBB, that would be my guess. Okay, this is the center of a cluster of galaxies. So this is a different type that I haven't told you about. Probably a CD galaxy, a cluster-dominant galaxy. So in the centers of some clusters of galaxies, there is conglomerations of what has happened to some other galaxies, and possibly there was a galaxy there to begin with, but it's now called cluster-dominant. This appears to have actually two galaxies colliding in the center there. This is just probably hot gas from hot as imaged in the X-ray. Okay, this is spiral peculiar off here. There is another galaxy warping this galaxy gravitationally. So this is a galaxy collision, and it's some kind of spiral. I would say, it's hard to say where the center is. Maybe it was here. This is probably an S, well, it's kind of, maybe an SC galaxy, peculiar. P for peculiar. Okay, back to Centaurus A. We did that one already. Okay, this is a ring galaxy. I'm going to pick it up again because we're running low on time. A ring galaxy. Okay, Messier 110. Looks to be like an elliptical galaxy. In a height, it's either an S0 or like an E7 type galaxy. Very elongated. Okay, here are two interacting galaxies. This is definitely some kind of spiral. It's definitely some kind of barred spiral. I'm not sure what that one was. Together they're called the mice, and there's very long, detailed tail of star formation there. Here's a relatively normal spiral down there. So colliding galaxies. When galaxies collide, typically the stars inside them don't collide. Galaxies are very empty. They're mostly empty space and very small volume of stars. Okay, here's a spiral that's being stretched by another collision. It might be with this one. There might be something off this. So this looks like it was an SB galaxy before it collided with something. So we take pictures of colliding galaxies more than non-colliding galaxies because they're more interesting. Okay, this is the small Magellanic Cloud here. You can see it with the unaided eye from the southern hemisphere. This is a globular cluster. It's a comparison. The image can show you this. That might be even another globular cluster. So this is in our galaxy. I believe this is in our galaxy too, a smaller one. But this is a satellite galaxy to our own galaxy. Okay, this looks to be, I don't know. It's a galaxy seen mostly sideways, almost sideways. It's definitely spiral. It could be a normal spiral. It's tough to tell the nucleus, but the nucleus does look small, so I'll call it an SC, though it's not very sprawling. So this is an elliptical galaxy, which actually has a rotating disk, so it's an unusual elliptical. Picking it up again, colliding galaxies called the antennae. At least one of them was a spiral. Ooh, a tremendous spiral. This is an SBC galaxy. Tremendous spiral arms. Of all the galaxies we've seen, I would guess this is the closest to our own Milky Way galaxy. We know our Milky Way has a bar. We know it's got these amazing spiral arms. So it might be, here's another galaxy it's colliding with, though. So we're actually most similar in my eye to NGC 1232. This is the LMC, the Large Magellanic Cloud, the other satellite galaxy of the Milky Way, visible with the unaided eye from the southern hemisphere. This is the Tarantula Nebula. Remember that. A peculiar spiral, some kind of collision. Okay, moving faster again. This is a cluster of galaxies. All of these are galaxies. In clusters of galaxies, elliptical galaxies are more common than away from clusters of galaxies. So there's a collision here. It's called the guitar because it looks like a guitar. But many of these galaxies are ellipticals. A peculiar spiral. A galaxy that originally was an elliptical, but it collided with something to give all this dust. So it's now just two colliding galaxies. Spiral that also collided, unusual, seems to have two dust lanes. I would say this is SB. No, S small b. Okay, there's gravitational lensing going on in this galaxy, in this cluster galaxy. So here you see a cluster, galaxy, 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 galaxy. Almost all the points you see here are cluster galaxies. There's a spiral in the center. Might be a ring, hard to tell. These elongated features you see here, These are galaxies far in the distance. And the gravitational lens nature of the cluster of galaxies is stretching the images, not the galaxies, but stretching the images of these far background galaxies into these long structures. It's sort of like looking through a wine glass and seeing things that are stretched out. It doesn't mean the thing in the background is stretched out. If you look backwards through a wine glass system, a wine glass you would see, or a double wine glass, you could see a lot of strange patterns. Two colliding galaxies, both spirals. This image is particularly interesting because you can estimate what the background galaxy looks like, and you can see that galaxies are, at least these galaxies, are mostly transparent if you look down on their faces, whereas spiral galaxies are not transparent when you look at them sideways. Okay, the Perseus cluster of galaxies, again, almost everything you see here, every spot you see here practically is a galaxy in itself. And since it's in clusters, there's many, many more ellipticals than spirals. Coma cluster, two big groups of galaxies, a nearby sort of binary cluster of galaxies that's studied in tremendous detail. Okay, a lenticular galaxy in S0, but it's peculiar because it seems to have these circular dust lanes. Centaurus A, we've seen a couple times. This is the very center of it, where you can see a tremendous amount of young stars forming there. Okay, radiolobes, this is a galaxy, I don't remember the type, but it's sending out these lobes. It might be an elliptical. These lobes which you can see in radio, which are covering the sky. Moving quickly, again, there's 5 images of a quasar visible here. So there's one quasar in the background of this cluster of galaxies, and you can see 5 images of it. 1, 2, 3, 4, and where the 5th is, I don't know. It might be in there somewhere. You can see also elongations from background galaxies that their images got distorted, but they're fine. This galaxy being stretched by that galaxy. Again, gravitational lensing, all these, you look very faint, and you can see, many of these features, these apparently stretched features. Back to the Andromeda Galaxy. Again, it's part of a local group, which we'll cover next time, and one of the most photogenic galaxies, well, probably the most photogenic galaxy, because it's so close, we can see a tremendous amount of detail. And that does it, but we're going to do the astronomy pictures of the day in the last 5 minutes. So let's go back in time to this one, okay? So back on November 6th of 2008, there was APOD featured a picture of Jupiter. That's one of the highest resolution images. It's advertised as the sharpest picture of Jupiter ever taken from the ground. It was taken in infrared light with what's called adaptive optics, sort of rubber mirrors correcting for atmospheric distortions. So this image has similar resolution to the Hubble Space Telescope. You can see a tremendous amount of detail. It looks dark because you're looking at it in infrared light. And so what you're seeing is what glows in infrared, and what is dark in infrared is superimposed on it. And the haze that's high in Jupiter's atmosphere is particularly prominent. Okay. Here you see a region of the sky taken in several views. There are 3. This is the Milky Way galaxy. There's 3 particular nebula visible there. There's the Butterfly Nebula here. Looks a bit like a butterfly. Okay, forgetting the names. The second one is the Crescent Nebula and the Tulip Nebula. Here's the Crescent Nebula, and here's the Tulip Nebula. So they're an odd trio that can be seen near each other on the sky. Last month, for the first time, it was actually predicted when a small asteroid, a large rock, would hit the Earth. But unfortunately, it hit over an African country. Which one was that? I don't know. It might say here. Sudan. And there was nobody there's no clear eyewitnesses that have come forward that I know of at this time. However, there is images that were taken afterwards, not of the asteroid, which is a big rock zipping across the sky, but of the trail it left, which is similar to the trails made by rockets going up. So that's the smoke trail dispersing. So we've seen this image before. This is 2 black holes dancing in the center of 3C75. So this galaxy has 2 black holes in it, and they're orbiting each other, and they will eventually coalesce in probably a big burst of gravitational radiation, if not other types of radiation. And here you can see infalling or outflowing gas that's being left behind. So here's the center of our galaxy pictured. This was similar to what we've seen last lecture. You might remember this feature here. This is the central radio arc. So this is the central radio. Actually, I can click on it and I'll bring it right up so you can see it. Let's see. Galactic center radio arc. Remember it? You see this one from last lecture? So now let's go back, and that is what we're seeing here. Except now this is a broader picture, and you can see more features around the galactic center, and many of these are formed in the radio, where what you're seeing is you're seeing this image in the radio, and it's molecules that are generally producing the radio emission, although most of the mass is in, well, dark matter and stars. So it's called the galaxy's central molecular zone. Okay, this is the Tarantula Nebula, which is in the LMC, which I said, remember this. So it is probably the largest star-forming region in the local group of galaxies. It is tremendously large and complex, and a bright supernova, supernova 1987A, occurred in 1987. This covers 60 full moons in size. It's just too dim to see, and you would need to be in the southern hemisphere to see it. And if this was as close as the Orion star-forming region, if this star-forming region was that close, it would cast shadows. It would be tremendous to see in the sky, and it would cast shadows. So the Phoenix lander, which was operating for most of this semester, now has stopped operating. I don't think they're going to get it back. This is a color image created from it. So this is, I think this feature is called Holy Cow, because when Phoenix landed, it's created such winds when it landed so as to expose surface ice. So this is normal water ice. And when scientists saw this, they said, holy cow. So Phoenix has scooped a lot of data, a lot of soil into its ovens and taken lots of detailed pictures, trying to find out if the surface of Mars, first of all, had any obvious life, which it didn't, or was conducive to life now or in the past, which they're still studying. And we're finding out whether this part of Mars even has features that are conducive to life. The water itself is a good sign, because life likes water, at least the life we know about likes water. So this puts us at today's picture of the day. I believe today is the 12th, so there's nothing for tomorrow. And I will see you then next week when we will jump out and explore the universe even more. See you then.